So this is me trying to show you with rather rough sketching the difference between 1 minus norm dist and just norm dist itself. So first of all, you have a question. Let's say they say that the mean is 350. What's the probability of 335 or less? So always draw a sketch, even though it's kind of a little rough like mine. Now, you can see that we've got the mean of 350. Now the mean is always in the middle, isn't it, in a normal distribution, so you can label that 350. Less than 335, we want to get this area to the left of 335. In other words, it's this red patch here that we want to try and get. So all we need to do is to go equals norm dot dist. If you're using Excel 2010, you need that dot in there, otherwise you just put norm dist. If your computer at home, etc., isn't the latest model, never mind, just norm dist. Then we put in the x value. So this value here, that's what we're calling x. So it's below 335. The mean is 350, which we have here, isn't it? The mean runs right through the middle. And then the standard deviation, which will be given in the question, that's the standard deviation. And for these questions, we always put true, T-R-U-E, true. And the answer that comes out from Excel, I forgot what it is, 0.00, something like that, is this area here. This is what we're doing. Norm dist gives you an area. So the area of the whole thing, the whole curve, the whole distribution is 1. So this bit, remember Excel, the key thing, adds up from the smallest to the largest. This bit here, up to 335, is worth 0.00, which is a share of 1. That's what that is. Okay, now let's turn to another question when perhaps we're asked, what if it's greater than? Something is greater than. This is when we're going to need to use that norm 1 minus. Okay, so let's say we use the same thing, but let's say that you've got some sort of a curve here, and the mean, let's keep the mean as the same as 350. So the question is, what's the probability of being greater than, I don't know, 375, say. 375 is here. So the question was more than. Notice that word more than or greater than. More than or greater than 375. So remember, Excel adds up to the left, so we have to be careful what we put in. It's going to add up going along on the left, from the left to 375. Actually, what we want though, is this area here to the right, isn't it? That's what we want. I'm just trying to color it in here, okay? We want that area here, which is more than 375. So we have to be careful what we write, because if we just write now let's try, okay? Can you see equals norm dot dist, and then we go 375, 350, and then 10 and true. That is going to give us the bit from the smallest value up to 375. That's what it's going to give. But actually we want from 375 onwards to here, don't we? This is the part we want here, the bit in red, this bit here, right? So that's why we need to calculate this number here, and then we go 1 minus it, whatever it is, and that will give you the area from 375 to the top. Okay, because what we calculated here was from the smallest value to 350. The whole thing, the whole distribution is worth 1. So if we go from here to here and then subtract it from 1, we'll get that bit left. Okay, just here's an example. You've got $10 in your pocket, which would be the whole distribution. You spend 8. How much have you got left? 1 minus 8, or 10 minus 8 equals 2. Right, you got that. Okay, now let's just try one with norm inv. Now, norm inv. Now, norm inv is a little different, because norm inv is when you know the probability and you want to find the x value, or the random value, that gives you that probability. Okay, you'll always be given the mean. I'm so sorry about this drawing, I'm just not very good. Okay, so let's say that the question is, you know that, I think it's in the slides, is that 22% of people don't eat enough vegetables. We're asked, what is the x value that separates the people who don't eat enough vegetables? That would be the people to the left and the people to the right. So before, we put in the x value and we got a probability. Now we know the probability. We want to calculate this x value. And so we can use equals norm in for that one. Equals norm inv. And here we know the probability was 0.22. And then you put in the mean and the standard deviation. And whatever comes out of that will be this number here, which separates the 22%, the 0.22, from the other 0.78%. Now, let's just try a new one where this is sometimes a little puzzling for people, is when we want to find out how much above, okay? So let's say that we have some distribution here, and for example, in that wine shop question in the Keynes, it says that something like 23% of customers buy wine above a certain amount. Okay, so we know that this area here is 23%. We know that that area there is 23%. They buy 23% of them buy wine above a certain amount. Now, if we just put in equals norm in 0.23 into Excel, remember Excel adds up from the left. It's going to give you this one. It's going to give you that 23%, isn't it? Because it'll think that you mean below, because for Excel it doesn't know whether you mean above or below. So we can think of this x value is 23% are above it, therefore 77% must be below it here. That's 77%, isn't it? All the way across. So now you can write equals norm inv 0.77, and then the other stuff like the mean and the standard deviation, 10. And that will give you this x value, so that 23% of people are above it, because 77% of people are below it. Thank you.